give you a sense of scale, you see our van right there, and there's a porta-john. This is a huge wastewater holding facility in South Atlanta. And we scanned it to give the excavator these deliverables to show them where they needed to excavate more and less. That's the scanner right there, and it emits light. It's LiDAR, 50,000 points a second. Accuracy is 1/8 of an inch on 1,000 feet. So we can see a long way and collect a lot of information with one scan. We do large volume scanning, so this is like an entire facility. And whether you're going to do the HVAC, whether you're going to do add another wing onto a facility, whether you're going to do the machines inside of there, this permanently captures everything that was there on site that day. And I was going to take this out, but it's just pretty cool. This is the Daytona Motor Speedway. We scanned all the bleachers there for the structural people. And it's just, cool to think that you can have every segment of all the structural columns in that place mapped. However, that's like 1.5 miles or something like that. So, 2D drawings, high tech can still do low tech. This is a storm sewer underneath the airport in Little Rock, Arkansas. And we're confined space certified, so we sent our guys down there and scanned the whole thing. It's buried in under buildings and under asphalt, so they wanted to see where it was so they can start doing some more construction around that area. And that's the 2D deliverable we gave them. 3D modeling, we still that's a big part of what we do. And just to show you, there's no upward end of what we can do with it. We did this petroleum refinery. And the video is kind of grainy since we produced the video several years ago. This is sort of an older project, but still all the data is there, just gigabyte upon gigabyte of data points. And you can see what, the model is going to come in on those points, and we gave them a working 3D model that I'm sure they're still using today. Now, spherical photography, that's something that just comes along with this. It's not quite as simple as this, but button A does the scanning, and button B takes high definition photography around. And you can see everywhere we set up, there's a triangle there. And you can click on that triangle and look at the photography around 3D. So this is helpful. You can virtually visit the site anytime. And since it's backed up by point cloud data, you can measure things and you capture these views, save them or print them, show them to other people. Is a collaborative tool for sure. And it's it takes a few minutes to generate this at the end of our project, so it's a free product. There's a couple more views right there. Being able to measure something that's up in the ceiling with this, just it's sometimes invaluable. Oops. Those are the two drones we have, and I'm actually trying to get a 330 COA exemption for this DJI Phantom right now, so we could use it in the field. And here's what one of our clients did, just to kind of show you how drones are really coming online. The left is a picture of the pre-tension rebar before they're about to pour the concrete. And once you pour the concrete, that disappears and you can't see it anymore. Well, what if you want to drill through the floor? Well, these guys on the right, they've draped it over a Revit model to where you can see that now. And it may not be accurate to the inch, but it's accurate to the foot, let's say. And clash detection, that's another good thing here. This is a study from Haskell. It's actually online. A wastewater holding facility, and the bottom picture here, as you see, if you see the red, that's where the model thinks that it should have been built, but the point cloud says otherwise. And they say in their study that they actually had to choose a different area to construct their whatever it was at the time. And that if they had found that out in the field, it would have slowed them down. It would have been additional cost. Here we scan Hartsfield Airport, and the contractor we worked for here was a baggage handling system installer. And so we took the model of their assembly and put it inside the point cloud, and everywhere it shows up red is where it's clashing with what's there now. And the kind of interesting thing there is that column right there wasn't in any of the plans, and so the guy just designed it straight through there. And since we're able to catch it now, we caught it before it was caught in the field, and also before they even fabricated the thing. So, you know, there was definitely a good bit of savings involved with clash detection in that project. We do a lot of work in Vegas, and I joke it's because our business development guy has a gambling problem. But then we did this for Penna Building Group, and they were building this theater, and they stopped when the real estate bubble collapsed. Well, now that the money's coming back, you know, what do we have? How far along in construction do we get? You know, does what they built match up with the plans, or maybe what we want to change? And so, you know, it's a good way to kind of come up to speed with what you've got, be able to compare it to the plans. And you could do this mid-project or at the beginning of the project. A couple of case studies here. These are online, Balfour Beatty, and it's really sort of the same thing. They've discovered, in the field, they discovered here was a steel channel was out of tolerance, and so they needed to measure, you know, 1,900 linear feet of that steel channel. So they did a study about what it would take to do a 3D laser scan versus a standard survey. And here's the breakdown. The scanning's up top, and they determined, you know, it was going to cost them $11,000 and 10 working days, whereas with standard surveying, it was going to cost them nearly $30,000 with 16 working days. So, you know, clearly that's a good application there. And then similarly, you know, I should have pointed out that these are sort of inaccessible, you know, 115, 120 feet above the ground. So that's, you know, clearly if you can detect something remotely, that's an advantage, and that's a big advantage of 3D scanning. So, you know, and the second one, same thing, you know, cheap scan, more expensive to do a survey, and, you know, ultimately the study that you can find online says that, you know, delivers faster and delivers less expensive, but it's also more accurate. Spatial analysis, that's just, you know, one other thing to talk about. We can do volumetrics. We can do, you know, regular topo with this. This is a big box retailer built on 40 feet of fill, the last 10 of which were construction debris. So we go there and scan it every couple of months to see it, you know, what's sinking now. Actually, this one sank so much that the pipes came out of the junction boxes. So, you know, that's bad. But, you know, you say there's no money in the budget. Well, there is money going to be spent on reworks and, you know, material and labor overestimates and that sort of stuff. So anyway, that's me. I'm David Headrick with Land Air Surveying, and just give us a call if you got any projects, and proposals are free. Thanks.